You may have heard the theory that it's possible there are multiple universes where you exist in each one but live a different life and make different decisions, resulting in a totally different outcome in each universe. We know this as the multiverse. But where did the idea for multiple universes come from? Today, we're going to confront the idea of the existence of a multiverse, as recent discoveries in physics and astronomy could point to their existence. Have we finally found evidence for a parallel universe? Or is it something stranger we cannot comprehend? The universe that we know and exist in all began with the Big Bang, which expanded faster than the speed of light in a growth spurt called inflation. And for as long as there has been a universe, space has been expanding ever since it came into existence 13.8 billion years ago. And it continues to expand. As far as we know, our universe is a single expanding blob of space-time, speckled with trillions of galaxies that now stretches 93 billion light-years from edge to edge. But beyond this limit, there are things we cannot see that could be something more, or just an infinite expanse of nothingness. Our universe might be really, really big, but also finite, or it could be infinitely big. Both of these things are possibilities. However, if the universe is infinitely big, there are only so many ways that matter can arrange itself within that universe, and eventually, matter has to repeat and arrange itself in similar ways. If the universe is without an end, then it might just be home to parallel universes. If that sounds confusing, think of a deck of cards. If you shuffle the deck, there are only so order orderings that can happen. And if you shuffle it enough times, the order of cards has to repeat. With an infinite universe and only a finite number of complexions of matter, the way matter arranges itself will also have to repeat. That said, if a multiverse does exist, there would also be infinite versions of you. Other alternate versions of you might be doing the same thing you're doing right now, but some might be wearing different clothes and probably made vastly different career and life choices. You might drive a Ford Fiesta in one world, but drive a Ferrari in another. But how could this be possible? Because the observable universe extends only as far as light has traveled in 13.7 billion years since the Big Bang, the space-time beyond this distance can be considered to be its own separate universe. And if this is true, then there would be a multitude of universes existing next to each other in a giant patchwork of universes. Although the idea of parallel universes or a multiverse remains a mystery, with some calling the idea pure science fiction, it's still one of the biggest debates between experts, with some believing they exist while others disagree. So now let's take a look at why some researchers think they exist and the unexplained scientific events that could actually be proof that parallel universes might exist. But first, we need a little bit of physics to understand everything. In quantum theory, an elementary particle such as an electron doesn't exist in a single state, but a multiplicity of locations, velocities, and orientations. One of those most famous logic-defying experiments in physics is called the double-slit experiment. Waves that pass through two narrow slits will form an interference pattern on a screen. It doesn't matter if it's light waves, water waves, or sound waves. However, light isn't only a wave, it's also a particle called a photon. Now, here's where it starts to get weird. If you shoot a photon through the double slits, it still forms an interference pattern, as if the photon was traveling through both slits at the same time. But here's where it gets more bizarre. Just by observing the double-slit experiment, the behavior of the photon changes. Even if the photons are sent through the slits one at a time, there is still a wave present that produces the interference pattern. This is a wave of probability, because the experiment is set up so the scientists don't know which of the two slits the single photon will pass through. But if they try to find out which slit the photon really goes through by setting up detectors in front of each slit, then the interference pattern doesn't show up at all. So the scientists tried a variation on the double-slit experiment and placed a special crystal at each slit that would split any incoming photon into an identical pair. One photon should create the standard interference pattern, while the other would travel to the detector. But the strangest thing is that it still didn't work. This means that observing a photon can change events that have already happened. This is still one of the greatest mysteries of quantum mechanics. From a physics point of view, parallel universes are one of those imaginative and compelling theories that's very difficult to test, if not impossible. However, the idea of many worlds began in 1926, when physicist Erwin Schrödinger demonstrated that the subatomic world is fundamentally blurry. In our familiar human-scale reality, an object exists in one well-defined place. Put your phone on the table next to you, and it's in the only place it can be, regardless if you're looking at it or not. But in the quantum realm, objects exist in a small state of probability and snap into focus only when observed. Before you look at an object, whether it's an electron or an atom, it's not in any definite location. It might be more likely that you observe the object in one place or another, but it's not located in a particular place. After nearly a century of experimentation, this phenomenon is a core aspect of the physical world. It might sound crazy, and even Einstein struggled with the idea. What happened to all the other possible locations where the object could have been? And why should an object's behavior depend on whether or not somebody was looking at it? Someone was bound to come up with a radical explanation for this phenomenon. And in 1957, a man by the name of Hugh Everett III, while he was
An apprenticeship will change your life forever. One day I want to have my own successful electrical company and provide opportunities that I had to other people in the community.
Learn and earn. Visit vic.gov.au/learn and earn.
Creating a more sustainable future for Victoria starts with your small actions. You can make a big impact by correctly sorting all of your recycling. But it's not just recycling correctly that makes a difference, but choosing to reduce waste every day. They might seem small, but these actions make a big impact on Victoria's sustainable future. Learn more at sustainability.vic.gov.au. Authorised by the Victorian Government, 1 Treasury Place, Melbourne.
having a conversation with friends about physics. It was then he came up with the wild idea about how to fix this most perplexing problem in quantum mechanics. Therefore, Everett imagined a multiverse full of different realms in which all the possibilities dictated by quantum mechanics could exist at once. He proposed that all possible outcomes really do occur, but that only a single version plays out in the world we live in. All the other possibilities split off from us, with each one giving rise in its own separate world, and everything that can happen does happen in some world. All of this sounded really bizarre, and no one would take Everett seriously at the time. But now, some physicists are considering the possibility of a multiverse. In fact, theories of cosmology, quantum physics, and the very philosophy of science have some problems that could be solved if a multiverse existed. Along with the idea of multiple universes created by infinitely extending space-time, other universes could also come into existence from a theory called eternal inflation. We already talked about how the universe we're in expanded rapidly after the Big Bang and inflated somewhat like a balloon. Eternal inflation theorizes that some pockets of space stop inflating while others continue to inflate, giving the rise to many isolated bubble universes. That said, our own universe could be just a separate bubble in the vast sea of space that contains other bubble universes like ours. There's even another idea which comes from string theory called brane worlds, which are parallel universes that hover out of reach to our own. This theory is centered around the idea that there could be many more dimensions to our world besides the 3 space dimensions and the dimension of time. These 3-dimensional brane worlds could exist in a higher dimensional space. So, is it possible that a multiverse or parallel universes could exist? Well, recently there was a scientific experiment done, and the outcome was evidence of parallel universes. In 2016, a group of NASA scientists were working with NASA's Antarctic Impulsive Transient Antenna, or ANITA for short. It's a high-altitude helium balloon with an array of radio antennas. This instrument was designed to detect ultra-high energy cosmic ray neutrinos, which are high energy particles 1,000,000 times more powerful than anything we can create on Earth. And they're the only neutrinos that can reach Earth without being weakened or reduced. Low-energy subatomic neutrinos with a mass close to zero can pass completely through Earth. However, high-energy particles would be stopped by the planet's solid matter, which is why high-energy particles are detected coming down from space, and a constant wind of these high-energy particles falls to Earth. But the team of NASA scientists were surprised when ANITA detected heavier particles called tau neutrinos coming up out of the Earth. If the particles were indeed real, it would mean that they would have been traveling back in time and could be evidence of a parallel universe. But this would also mean that the parallel universe would be running backwards in time. But the interesting thing about this is that if there were any inhabitants in this possible parallel universe, they would see us as the ones moving backwards in time. So what's really going on here? No one is certain yet, but the main investigator of ANITA said that they encountered a small number of anomalies in their data, and once they've exhausted all the possible explanations within the standard model of physics, only then will it be time to consider ideas that push those boundaries. But more evidence has been found out in space that could point to the existence of parallel universes. There are significant events in time and space that leave their marks on the cosmos, and the Big Bang left its footprint on everything we observe today. Recently, the European Space Agency's Planck satellite mapped the cosmic microwave background, the primordial microwave radiation that fills the known universe. This relic radiation is a perfect record of our universe from the moment it inflated and expanded. At first glance, the CMB looks to have a uniform temperature, but at micro-Kelvin scales, you can see variations in temperature in the form of hot and cold patches. This is due to tiny quantum density fluctuations that occurred when the universe was just born, meaning that matter wasn't even distributed, and some areas of the universe are more densely packed than others. But there's an intriguing mystery which concerns a large and unusually cold patch on the CMB, which is an astounding 1.8 billion light-years across. This CMB cold spot is much colder than the average CMB temperature, and this strange cold spot appears in the southern celestial hemisphere. Some researchers previously thought this space could be cooler simply because it had less matter than most sections of space. However, in a recently published survey of galaxies, astronomers say that this cold supervoid should not exist. And in a separate study, simulations suggested there was only a 2% probability that this cold spot formed randomly. However, researchers cannot entirely rule out the possibility. But if this is not the answer, then there could be more exotic explanations. One of those is that the cold spot was created by a collision between our universe and another bubble universe. Black holes are a major quandary when it comes to our understanding of physics because either they can destroy information, which contradicts what we know about quantum mechanics, or they disregard Einstein's theory of relativity. Now scientists are applying the many worlds theory, now called Everettian, to the black hole information problem. By using the many worlds interpretation, scientists are finding new ways to answer mysterious questions about black holes. Who knows, maybe black holes could have something to do with parallel worlds.